This video is for section 5-8, problems involving fractions. Here's a reminder about our four-step problem solving plan. Use a variable to represent described numbers in the word problem. Form an open sentence, usually that means an equation, but sometimes inequalities, using the facts given in the problem, and solve the open sentence. And then make sure you check your result with the requirements given in the problem. We've also discussed some supporting strategies that help you to work that four-step plan. Sometimes you need to use a math formula. Other times, drawing a diagram helps. And other times, organizing information in a table helps. Here's an example problem. One computer system can prepare a company's weekly payroll in 12 hours. A faster system can do the job in 8 hours. If both systems are operating, how rapidly could the payroll be processed? If you were to take a guess at the answer, what would you guess? If the company only had this faster system, it would take 8 hours, but with both systems operating, it should take less than 8 hours. We're expecting an answer that's less than 8 hours. Let's follow the four-step plan. First, choose a variable. We're asked for how rapidly could the payroll be processed. That's asking us for the time that it takes. So we might use the variable t to represent time. To help us create expressions that use t from the facts of the problem, let's use a math formula. Work equals rate times time. The first computer system, the slower system, can complete 1/12 of the job in 1 hour. So its rate is 1/12. And the time that it works is t. The second computer system, the faster system, can complete 1/8 of the payroll job in an hour. And its time is t. The company is using both systems, so we add together the work from the first system plus the work from the second system to equal the total amount of work, which is 1 payroll job. This expression is the work from the first computer system. This expression is the work from the second computer system, and adding them together is 1 payroll job. Now solve the equation. In the very last lesson, we learned techniques to solve equations that have fractions. One is to multiply by the least common denominator. The least common denominator with a 12 and an 8 is the number 24. 24 times 1/12t is 2t. 24 times 1/8 t is 3t. 24 times 1 is 24. This makes 5t equals 24, so t equals 24/5. Because we're asked how much time it takes to complete the payroll job, it doesn't make much sense to leave the answer as an improper fraction. This is the mixed number 5 4/5, and t is measured in hours. Working together, the computers can complete the payroll in 5 4/5 hours. Real-world situations often involve percent. Here's a reminder of what a percent is. It is a fraction whose denominator is 100. For example, 32% is the fraction 32 hundredths. 5% is the fraction 5 hundredths. Whenever you see a percent, you can think of it as a fraction. A percentage is the product of a percent and a number which is called the base. A common example of finding a percentage is when you calculate a tip at a restaurant. It's common to leave a 15% tip. Let's say that you spend $20 on the meal, and you would need to know what 15% of $20 is. That is an example of a percentage. 10% of $20 is $2, 5% is $1, and 2 plus 1 is $3. The $3 tip is a percentage. It is the product of a percent times the base of 20. Let's try another example word problem. A 15-ounce solution of alcohol in water is 75% alcohol. At most, how many ounces of a 67% solution can be added if the final solution is to be at least 72% alcohol? Students who have had chemistry class may have an advantage on this problem because this is the kind of math that they do in that class. Let's make sense of the situation. We have a solution to begin with. My abbreviation for the word solution is SOL''N. We're told that we're adding another solution to the beginning solution. And we're told that that creates a final solution. I'm writing down this little diagram to help me organize the information. From the first sentence, we can figure out how much alcohol is in the beginning solution. There are 15 ounces of liquid, and 75% of that is alcohol. So 75% of the 15 ounces is actually alcohol. The rest of it is water. The expression 0.75 times 15 represents that. We're adding another solution, but we don't know how many ounces we're adding. In fact, that's what we're asked to figure out. So when we choose a variable, we will use that variable to represent how many ounces of that new solution we're adding. Let's choose the letter X for that. We know that it is 67% alcohol. So 0.67 times the amount of that solution is actually alcohol. The rest of it is water. When we mix the beginning solution and that new solution together, it creates a final solution. And we're told that that has to be at least 72% alcohol. The symbol for at least is greater than or equal to. 72% is the decimal 0.72. And we'll multiply that by the amount of that solution. We started with 15 ounces and added X ounces. So the amount of the final solution is the expression 15 plus X. 72% of that is alcohol. The rest of it is water. We have completed the first parts of the problem-solving plan. We selected the letter X to be the number of ounces of solution we're adding. We represented the facts in the problem using algebra expressions, and we put them together into an open sentence. This time our open sentence was an inequality. Now solve. 75% of 15 is 11.25. .72 times 15 is 10.8. And 0.72 times x is 0.72x. Subtract the 0.72x from both sides. 0.67x subtract 0.72x is negative 0.05x. Subtract the 11.25 from both sides. 10.8 subtract 11.25 is negative 0.45. Divide by the negative 0.05. When dividing by a negative, reverse the arrow. Negative 0.45 divided by negative 0.05 is 9. Let's check this result against the requirements of the problem. What were we actually asked to figure out? How many ounces of solution could be added to make a final solution that is at least 72% alcohol? We found out that we could add not more than 9 ounces. Let's try one more example. You have two investments. One pays a 6% dividend. The other is $680 more than half the first, and it pays a 5% dividend. If the total return is $102, find the investments. First up, let's define variables. For our first investment, we might use the letter X for how much money we've put into that investment. For the second investment, we want to try to represent the amount of money in the second investment also using the letter X so that we don't introduce a second variable to the problem. In the second sentence, we're told that that second investment is $680 more than half the first. So it can be represented as 1/2 x plus 680. For each investment, we're told the dividend, the percent of the money that we get paid each year. 6% of the X dollars is the dividend from the first investment, plus 5% of the 1/2 x plus 680 is the dividend that we get paid from the second investment. When we add those interest payments together, we're told that we make $102 on the investment that year. Here's our open sentence. First step to solve it, the distributive property. 0.05 times 1/2 x is 0.025x. 0.05 times 680 is 34. Next up, combine like terms. 0.06x and 0.025x combines together to 0.085x. Next up, subtract 34 from both sides. And that makes 68. And final step, divide by the 0.085. With the help of a calculator, the answer is 800. Let's check that result against what we were actually asked to figure out. We were asked to find the investments. By figuring out X, we figured out how much money we put in the first investment, $800. But we still need to find how much money we put into the second investment. To find that, we're going to go 1/2 times 800 plus 680. That makes 1,080. Let's summarize the lesson. We did a few example word problems that use the kind of algebra skills that we've been practicing lately. To have success, you may need to read the word problems multiple times and use problem-solving strategies you know about, such as underlining or circling the facts as you find them, representing the thing you're asked to figure out with a variable, such as X, and using math formulas, such as the formula for work or the formula for finding interest on an investment.